Assalamualaikum and hi. So in this video, we want to present about evaluation and enhancement of road safety features, skid resistant, surface texture depth, and drainage efficiency on UiTM Shah Alam campus. So this is our team member, FARHAN, Azim, ZAMANI, ISWANDI, and IRFAN. For the introduction, this project focused on road pavement engineering, specifically skid-resistant, surface texture depth, and surface drainage. These elements are essential for vehicle safety, especially in wet conditions, as they reduce skidding and hydroplaning risk. Our goal is to understand how pavement characteristics affect road safety and to analyze practical tests like skid resistance and drainage. Finally, this project aligns with Sustainable Development Goal, supporting SDG 9 for industry and infrastructure, and SDG 11 for sustainable cities and communities.
Road pavement surface conditions play an important role in ensuring traffic safety, especially during wet weather. When pavement surface lose friction, texture, or drainage capability, the risk of skidding and hydroplaning increase. To evaluate these surface conditions, several field tests are commonly conducted. The skid resistance test measures the friction between vehicle tires and the road surface. The outflow meter test evaluates how efficiently water drains from the pavement. Meanwhile, the sand patch test determines the surface texture depth of the pavement. These tests help assess whether the pavement provides sufficient safety, durability, and performance for road users. Through this video, the procedure and significance of the skid-resistant outflow meter and sand patch test will be demonstrated.
First of all, this is the apparatus for skid resistant test, which is the skid resistant tester.
Before taking any readings, the skid resistance tester must be properly leveled. The equipment is placed on the test surface and adjusted until the bubble in the spirit level is centered.
Next step is to brush off any debris, dust, leaves, etc. from the surface of the pavement that will be tested to prevent any inaccuracy. Next step is adjust the pointer using the pointer adjustment screw so it indicates 0 when the pendulum is released freely and not touching the pavement.
The contact path length is adjusted to between 10 to 12 cm as required. This is done by setting the height and position of the rubber slider so that it makes proper contact with the test surface during the swing. Ensuring the correct contact length is important because it affects the friction measured by the pendulum. An incorrect contact path may lead to inaccurate skid resistance readings.
First, we conducted the test on a dry rough surface. The pendulum arm was released and catched to prevent backswing of the pendulum arms. First, we conducted the
Next, we measure on the wet rough surface and the skid resistance value was obtained.
This is the results for skid resistance test. For this test, each measurement was repeated 3 times and the average value was taken to obtain more reliable results. The same procedure was applied for both smooth and rough surfaces under dry and wet conditions. The smooth surface under dry condition recorded an average skid resistance of 49.33, which meets the JKR requirement. However, under wet condition, the value dropped to 31.67, which does not meet the specification, indicating a higher risk of skidding. For the rough surface, both dry and wet conditions showed good performance. The dry surface recorded 96.33, while the wet surface recorded 51.67, and both values satisfied the JKR requirement. Overall, the results show that rough surfaces provide better skid resistance compared to smooth surfaces. The higher skid resistance value obtained from the rough surface indicate better friction between the surface and tire, which helps to reduce the risk of skidding. This highlights the importance of surface texture in roads design to ensure safe driving conditions.
So now for the outflow meter test. The apparatus is outflow meter, stopwatch, and a bottle of water.
First, the rough surface was brushed to remove dust and loose particles before the apparatus was installed.
Then, the outflow meter apparatus was placed on the testing surface.
Next, Close the opening valve at the bottom of the outflow meter and fill water into the outflow meter apparatus up to 400 mm. Next, close the opening.
This is the outflow meter test. The stopwatch starts exactly when the stopcock is open to release the water. The measured outflow time recorded is about 7 seconds from start to finish. The outflow meter test shows that the smooth surface has an average outflow time of 11.6 seconds with a flow rate of 3.45 times 10 to the power of negative 5 meter cube per second. This indicating slower drainage and a potential risk of water ponding based on JKR guidelines. In comparison, the rough surface records a shorter outflow time of 7.6 seconds and a higher flow rate of 5.26 times 10 to the power negative 5 meter cube per second, which meets the JKR requirement for good drainage. Overall, the rough surface demonstrates better drainage performance than the smooth surface.
For sand patch test, the apparatus is brush, measuring cylinder, rubber disc spreader, and ruler.
Before conducting the sand patch test, the test surface is first brushed thoroughly to remove loose particles, dust, and debris. Before conducting the sand patch test,
Next, the amount of sand that will be used in the testing is measured by using measuring cylinder included in the sand patch kit.
Next, pour the 10 ml volume of sand onto the surface and spread the sand evenly in a circular motion. Next, finally, calculate the sand circle diameter and record the data.
The sand patch test is carried out to compare the surface texture of smooth and rough surface. From the result, we can see that the average diameter of smooth surface was 226 mm and MTD of 0.25 mm shows that the smooth surface has low macro texture that may increase the risk of skidding. For the rough surface, the average was 180 mm, resulting in lower MTD of 0.39 mm. The value is not fulfill the JKR specification due to small volume of sand because it limit the ability of the sand to fill the void and represent actual pavement macro texture. Overall, the results show a clear contrast between the two surfaces, where the smooth surface exhibited lower macro texture compared to the rough surface.
In summary, skid resistance, surface texture depth, and surface drainage are key factors in road safety. Adequate surface texture improve tire road friction and help reduce skidding and hydroplaning risk. Through field tests and data analysis, pavement performance can be evaluated effectively. Overall, the findings support better pavement design and maintenance, contributing to safer and more sustainable road infrastructure. That's all from us. Thank you.